Indices. Anytime we are writing. It's on the board. Exponent a certain number. Anytime we write a number, exponent a certain number, we call the number the base and the exponent the index. Into bracket, plural, indices. Oh. Full stop. Full stop. This simply means that's comma. This simply means multiplying the number, which is the base, so it's bracket base, by itself a certain number of times. A certain number of times. Full stop. A certain number of times. Full stop. The number, so we continue writing. The number 2 is the base, and the number 3 at the top is the index. Thus, comma 2 to the power 3 means. Who can explain this to us? 2 to the power 3. What does that mean? In indices. Who can multiply 2 by itself 3 times. Is it true? No, it's not true. 2 is the same thing I said. I said it's not true. 2 to the power 3 means what? 3 times. It is not true. Do it yourself on your paper. Is it true? 2 to the power 3. Watch here. 2 to the power 3. The same as what? 2. How many times did you see the sign? Twice. Why you tell me 3? It's wrong. You know how you are taught in secondary school? Thank God you have met me here. How many times did you see the symbol times? 2. So multiplying 2 by itself, how many times? 2 times. That's 2 to the power 3. Yes. Go anywhere in this world. That is what it means. How many times do you see the symbol times there? Yes. This one, to know the number of times, subtract 1 from 8. That's the meaning. That's what you do in mathematics. That is power. That's the number of times you multiply it by itself. Minus 1. Are you all here? Yes. So 2 to the power 3 means multiply 2 by itself twice. Full stop. Then come and write here. That is 2 to the power 3 is equal to 2 times 2 times 2. Watch here, everybody. Watch the multiplication, please. Stop writing and watch. Hands up, everybody. Hands up. Now watch. What are you going to do? Watch here. If you multiply 2 by 2, what do you get? 4. What are you going to do again? You are going to multiply 4 by what? 2. What do you get? How many times did you multiply? Hey, who said 3? Hey, we only multiplied 2. By 2 we had 4. That's one time. After I multiply 4 by 2, that's second time. Huh? Who misled you in your secondary school? No. Huh? Should we go on? Laws of what? Indices. 1. Anytime you have a number to a certain power multiplied by the same number to another different power. Are you all here? What do you do? To a certain power. What do you do? The same numbers. You write the number down, then you sum the powers. Can you all see? Yes. You sum the powers. An example is this. If I say 2 to the power 3 times 2 to the power 4. The bases are what? The same. So we now know what the base is from the previous explanation. So 2 to the power 3 plus what? 4. So what do we get? 2 to the power 7. Are you all here? Yes. 2. When you have an indices dividing another indices such that the bases are the same, the numbers are the same. This is the same as if you write a power m over a power n. Can you all see? Here you write the number down, write the top power minus what? The down power. Example. 2 to the power 3, 2 to the power 4 over 2 to the power 2. So what do we do? 2 to the power 4 minus what? 2. 2 to the power 2 is equal to what? Is it 4? Yes. Any question? The third one and the final is what? Whenever you have an indices to another power. Are you here? What do you do to the powers? You multiply them. M times what? N. Are you all here? Yes. M times N. E.g., if you say 2 to the power 3 or to the power 2, it's the same as 2 to the power 3 times 2. So I'm going to get 2 to the power 6. 2 to the power 6 is what? 2 to the power 6 is what? Any question? I hope I can clean here. B is the same. Are you all here? Can you see what I've just written? A over B all to the power n. So pick A. So example, if I have 2 over 3 all to the power 2. This is what we are saying. So write the top to the power, write it down to the power. Can you all see? Yes. 2 square is what? 4. 3 square. Any question? Any question? When you also write, here they were dividing, now they are multiplying to the power n. You separate them, you will still get the same answer. That's the meaning of this property. That's the meaning of this property. E.g., when you have 2 times 3 to the power 2, the same as 2 to the power 2 times 3 to the power 2. 2 square 4, 3 square 9. 4 times 9 is what? It's what? 6. Multiply 2 times 3 and square it. Will you get the same answer? Multiply 2 times 3 and square it. Will you get the same answer? Yes, that's the meaning of the property. Can you hear? Can you see that? Yes. Are you all here? Anytime you raise a non-zero number to the power 0, you get what? 1. Are you all here? Anytime you raise a non-zero number to the power 0, you get what? 1. So B is not 0. 0 to the power 0 is what? 0 to the power 0 is what? 0 to the power 0 is what? You are holding on and cannot still give the answer. 0 to the power 0 is what? I'll bring it to your example. So you are saying that any number to the power 0, so even if you say 1000 to the power 0 is what? 1. As long as the number is not 0, that's what is a non-zero. So take note of that. I hope you are not confused, Nasiba. Are you following? Okay. If you pick a number to the power negative 1, pick a number to the power negative 1, it's the same as 1 over the number. Are you all here? It's the same as what? 1 over the number. So if you write 2 to the power negative 1 is the same as 1 over what? 2. Can you see that? Yes. What about if it is a number to the power negative of a certain number other than 1? It's not 1. Can you see? Here is what? Negative 1. Now it is negative something, not 1. Can you all see? Are you watching? Can you see? A is not 0, and it's not also 0, and it's not also 1. Can you see? Yes. So who can tell us? This one is the same as what? 1 over what? A to the power n. How did they get 1 over a to the power n? Who can tell us? From the laws. Let's see. Who can remember something? Who can remember something? Who can rewrite a to the power negative n from in another way? One of the laws. Somebody should remember. Who can remember? How? What other way can you write a power negative n? It's the same as what? A to the power n or to the power negative 1. Is it not true? Yes. And look at this property. Anytime you have something to the power negative 1, it's the same as what? 1 over that thing. So it is this thing to the power negative 1. So that's why we write it as what? 1 over a power n. Are you all here? Yes. Any question? An example. If you write 2 to the power negative 3, it's the same as 1 over 2 to the power 3. So we get 1 over what? 2 to the power 3 is what? 8. 2 to the power 3 is what? 8. Any question? Any question? If you also write, if you have a fraction, are you watching? A over b. If you have a fraction a over b to the power negative 1. Are you watching? We are still following the trend. Can you see? Are you watching? Look at the trend. Anytime it's something to the power negative 1, what do? What do? Let me give you the answer, and then you will tell me how we had the answer. B over what? A. A over b to the power negative 1 is the same as b over a. Who can tell us how did we get this? From here, can you see? Can you see? Who can tell us? A over b to the power negative 1. To the power negative 1 is the same as what? 1 over what? A over b. Is that not it? So how do you simplify this? You multiply by what? Reciprocal. Can you see? Are you all here? You multiply by what? Reciprocal of this. And reciprocal of this what? B over what? E. Multiply here also by what? B over what? E. This cancels. This cancels. So we are left with what? 1 times B over A. So we get what? B over E. So that is why this is the same as this. What take your hands for me? You think it's easy? To the power negative n is equal to equal to what? B over A. On M. Negative part. You should use 2M. Okay. So we are saying that it is the same as 3 over 2 all to the positive power. Positive power is what? 2. Class, let's verify this from what I said to you. Mobile. All square. What do you get? You remember another law? Can you see? This one means take the reciprocal and change the power to positive. Then come here. You remember one of the properties that says that when something is divided by something to a certain power, what do? You can separate them. Is that not it? You can separate them. So what do you get? Never what? 4. You want to change it. 9 over 4 is the same as what? Is it 2 whole number? 2 whole number or 1 whole number? Can you see? They say that in mathematics, a bigger object should not sit on a smaller object. Is that not it? So anytime you have a result in that form, change it to the next form so that the denominator will be bigger than the numerator. Are you all here? Yes. So 8. The root. So if you have a to the power 1 over any number other than 1 or 0, it is the same as that root of the number. Can you see? So the denominator is what? N. So it is what? N root of A. Are you all watching? Anytime you have an index such that the index is 1 over a certain number, which is not 1 and it is not 0. The denominator of that index is not 1 and it's not 0. This is what it means. Take that root, the denominator of that. So if it is 3 here, it means what? Take the cube root. Are you all here? So let's solve an example and you see. So if you have an example like this, if you have an example like this, 27, are you watching? To the power 1 over 3. What is our n? 3. Can you see? We are taking nth root of the number. Our number is 27. Our denominator of the index is what? 3. So we take the third cube root. Is that not it? Cube root of the number. So we are going to take cube root of what? 27. What is the cube root of 27? Yeah? It's what? It's 3. Cube root. So 3 to the power 3. So the cube root of 27 means 3 to the power 3 will give us 27. So this one, you are simplifying this. So cube root of this. What number will you raise to the power 3 to get 27? That's the meaning. Are you all here? Yes. So the cube root of 27 is what number will you raise to the power 3 to get 27? It is 3. Are you all here? Yes. You also have 81 to the power 1 over 4. Are you watching? You also have 81 to the power of 4 is the same as 4th root of what? 81. Can you take 4th root of 81? It's what? 3, eh? 27 times 3. Is it 81? Yes. So 3 times 3 times 3 times 3. So it's also what? 3. So 3 to the power 4 will give us 81. 3 to the power 3 will give us 27. That's the meaning. Are you all here? Huh? Property 9. If you have an initial equation where the bases are not the same, initial equation and the exponents are the same. Let's say the exponents are the same. Anytime you have an initial expression in this form where the exponents are the same, what do? Equate the basis. Are you all here? So whenever the exponents are the same, we equate the basis. Equate the basis. And okay, we are coming to the other one to us another property. So we have separated them, we are not combining them. So when you also have a situation where the bases are the same and the exponents are different, we equate the exponents. Here we equated the bases because the exponents were the same. Here the bases are the same, so we equate what the exponent. We will be solving examples on all that, so don't worry. Let's get the properties clear. So here it implies A is equal to B. So here it implies X is equal to Y. So when the bases are the same, we equate the exponents. Equate the exponents. Equate the exponents. Any question? Any question? If you have a number to the power a fraction, are you watching? To the power a fraction, it is the same as, like we have done the nth root. So you take the nth root of a and then to the power the numerator. So the denominator is the root of the base, and then the numerator is what? The power. Who can tell us how did they get this? Who can tell us what did they do to this one? A to the power m over n is the same as what? Who knows? A to the power m over n. What other way can we rewrite this one? It's the same as what? A to the power 1 over n. Can you see? To the power m. This is what they applied third law. Can you see third law is applied here? Third law, multiply the exponents. So when they multiply 1 over n times m, that's why they had m over n. Can you see? So this is how they had this. So from here, you now apply this property. So you now have a to the power 1 over n. Take the nth root of this, and there's a power this. So they change this one using law 3, which says power to a power. When there are two powers, you multiply the powers. That's the meaning. So they multiply m by 1 over n to get m over n here. So initially it was like this. So this is how you send it back. Then take the nth root of this, obeying property 8. Then you can now raise it to the power m. So you can have a simple example like this. If you have 3 to the power, if you have, let's use 27 to the power 2 over 3. Can you see? 27 to the power 2 over 3. Are you watching? 27 to the power 2 over 3. So we said you should take the denominator root of this. So you are going to take cube root of 27. After that, the answer you get, square it. Can you see? The denominator is the root. The denominator is the root of the number. After raising to the power, the numerator. Can you see? So when we take the cube root of 27, what do we get? Is it not 3? Cube root of 27 is 3 to the power 2. So what do we get? 9. So 27 to the power 2 over 3 is 9. My friend, sit well. How do you sit and raise your leg like this? Wait. So now we are coming to solve some examples using the laws and then the properties all together. See? Assuming you are having A over 1, B, all in bracket, to the power C over 1, D, D root of A over 1, B, to the power C, the same thing. And we did properties of stars, have you forgotten? So, of this, to the power this, to take that, the empty root of this, the root of this, raise each of them to the power. Can you see? Yes. Any other question? Any other question? Simplify the following. The following. So you mentioned them one by one. Once you finish solving the first one, then you mention the next. So 27 over 8 like this. All in bracket like this. To the power negative 2 over 3. So pens down and let's walk it together. Are you all here? So the question says, simplify into bracket 27 over 8 all to the power negative 2 over 3. What's an idea? What is coming into your mind already? Negative power. Negative power. That's the first thing. That's the first thing that should come to your mind. What property? Watch all the properties in your book. Everybody, watch in your book. What are the properties in your book? And tell me 27 over 8 all to the power negative 2 over 3 will be written as what? This power, negative power. Work it for me. How do you write? First, because it's negative and it's a fraction. First we write what? 8 over 1, 27. To the power. To the power. Is it 2 over 3 or negative? Is it positive or negative? It's positive. Very good. Thank God, you are following. You all get A plus, fraction, we just finished it. You remember? We just finished that one. So what do we do? Who can tell us? This one is the same as what? Who can tell us? What do we do? Cube root of what? Are you watching? We have just finished that one. The denominator, root of this. Is that not it? The denominator, root of this. So cube root of what? 8. Cube root of what? 27. Have you seen how I write cube root? Don't come and put it here. It's wrong. Are you watching? That's where it's supposed to be inside, not outside. So cube root of this, and then have we finished? So what do you do? We should do all square, right? All square. You are the one solving it for me. So what do you do next? You just simplify this first. So simplify for me. Cube root of 8 is the same as what? Is it 2? Cube root of 8 is the same as 2. Cube root of 27 is what? Power. Are you watching? The power is what? 2. Yes, nothing. So what do? We have 2 square, 3 square. Is that not it? Yes. Is it correct? Number. So the denominator is n. Cube root. This is the number. And then you raise the power of the numerator. So we have finished taking the cube root of the number. Then you now raise to the power of the numerator. Just like in the property. The whole number is a fraction. So you cannot take it and leave it. You apply the numerator. So you take the cube root of 8. Take the cube root of 27 as well. Are you here? So that's what we do. So after that, don't forget to raise it to the power of the numerator. So 2 square. Any question? In the same thing, that's another property you apply. So anyone you want to apply. If you make the cube root to cover all, it's the same thing. You have to still separate them. How the cube root of 8 is 2. Yes. So cube root. So any will you raise to the power 2? We'll come to that. We will solve many examples how to compute those kind of things. They're asking you that 8 is a number. What will you raise? What will you raise to the power 3 to get 8? Are you watching? Are you watching? So this is x to the power 3. Then, so you have x to the power 3. 8 can be rewritten as what? 2 to the power 3. Is that not it? If you raise 2 to the power 3, you get to have 8. We'll come to that. We are trying to solve this kind of equations. Can you see? The law says what? When the powers are what? They say, what do you do? You equate the bases. Can you see? When the powers are, they say, what do you do? Equate the bases. We'll be solving an example like that. So you are simplifying this. You're asking yourself, what can I raise to the power 3? Cube root means something to the power 3. To give it that number. So how will I raise the power 3 to get 8? So you can do that. Something to the power 3 must give me 8. So you now simplify this 2 to the power 3. This one in indices form is 2 to the power 3. And what the rule says when the powers are the same, what do you do? Equate the bases. So we are going to get x is 2. So that's why the cube root of 8 is what? 2. It's the same thing. Who's the class? What's the name? What is bracket? How much? 1 over 4. Is that all? 1 over 4. After that, you give us a different question. This is similar to this. Can you see? Anyway, this one was negative. This one is positive, so it's good. Are you there? So let's do a positive one for this. So, what did we say? If the power is what? 1 over anything. One of the properties. you take this root, the denominator root of each of them. Can you see? So we take what? 4 roots of what? 16. Then 4 root of what? 81. Can you all see? 4 root of 16 is what? 2. 4 root of 81. 3. Is it not true? Yes. So copy that quickly. Then give me. Copy quickly. Copy. 9. 9 is the power 2x minus 1, like this. Is equal to 1 over 27. Okay. Write a question and put your pens down. So the questions we are solving questions different forms. So this is another form that says that when you have an initial equation, what do we do to find the unknown variable? We have given a property that says that when the powers are the same, do what? Equate the bases. When the bases are the same, do what? Equate the exponents. So all we are coming to find out is how can we either make the powers the same or make the bases what? The same. Are you all here? Yes. So we can tell her, let's see, is there any way we can rewrite 1 over 27? 1 over 27. Let's leave this one for now. Are you watching something? This one is 9. Let's count. Let's rewrite the question first. 9 to the power 2x minus 1 is equal to 1 over 27. So this 1 over this. Indices. So let's change this right hand side to have an index, a power. So we can change this one to have a power. 1 over any number is the same as what? The number to the power negative 1. Are you watching? That's the first thing you should ask yourself. You are working indices. You already have an indices here. But this one is not written in indices form. So how do I make the side that is not written in indices form an indices? Can you all see? Yes. So anytime you have, that's one of the property we wrote. 1 over a, is that not it? Is equal to a to the power negative 1. So that is what we have just done. Are you all here? Yes. Now ask yourself, stop writing. Don't write, put your pens down. Don't be in a hurry, Whatever I teach you is where my questions will end. Are you all here? So don't be in a hurry. Make sure you always grab whatever I teach. You will need this, my lecture notes, one day when you become a lecturer or a teacher somewhere, maybe not in the university. And you remember, there was a young, smallish man.
The boss himself.
Who taught this topic very well. Let me look for his notes. And you are very fortunate. Our time, there was no internet. But you are lucky, there is YouTube. You can just go back and search my name anytime. It will take you to all my videos. And say, thank God. You will not suffer to teach those topics because I taught them very well. Are you all here? So make sure you grab it than the writing. The writing is not important. I give you the notes in PDF form and then I still give you videos. So what is your problem? So forget. Make sure you understand the concept. Whatever I'm teaching, understand before you write. So we are able to successfully change 1 over 27 into indices form. Now ask yourself, is there a way I can make these powers the same? If there's no way, you now ask yourself, is there a way I can make the bases the same? Are you all here? Yes. This is 9. The base here is 9. The base here is 27. Can I change this 27 to become 9? Or can I change this 9 to become 27? That's why you ask yourself first. If you can't, forget off making either the same as the other. Then you now come and ask yourself, is there any common way I can change this and change this and they will have the same base or the same power? Are you all here? Then you now go ahead. 9 and 27. What runs through them? 3. Can you see? So I can change this to have a base 3. I can change this to also have what? A base 3. Then I'm succeeding small. Can you see? Yes. Because the rule say one of the properties is when the bases are what? Equal, equate the powers. So we are going to see if we can make the bases to have a common term, a common value. So 9 is the same as what? 3 to the power 2. But don't forget, 9 alone is to the power what? 2x. Are you watching? Minus what? 1. Minus 1. Can you see? So do it this way. First, go to the 27. 27 alone is what? 3 to the power 3. Is it not true? Stop writing, my friend. 27 alone is what? 3 to the power 3. All to the power negative 1. Are you there? Yes. So, let's continue at the other side. 3 to the power 2, all to the power this. Then 3 to the power 3, all to the power negative 1. Who can tell us what property can we apply here? Or what law can we apply here? Law what? Law 3. Is that not it? Law 3 says when you have two powers, do what? Multiply the powers. Can you see? So in the exam, before you write your exams, make sure the laws, all the 3 laws are here. And all the 11 properties are also here. So that you will not fail my exam. If you know them, you just know that anytime you see two powers, multiply the powers. So this one is the same as 3. You come to multiply this. 2 into bracket. Are you watching? 2x minus 1. And this one, 3 to the power 3 times negative 1. Can you all see? Yes. Power 3 times negative 1. So let's simplify that quickly. We have 3 to the power 4x minus 1, 2. 3 to the power negative 1, 3. We said that when the bases, law 10, when the bases are what? The same. What do you do? You equate the power. So when the bases are what? The same. We what? We equate the powers. So what are our powers? The left hand side is what? 4x minus 1, 2. It's equal to what? Negative 3. How do we simplify this for x? 4x, is equal to negative 3 plus 2. 4x is equal to what? Negative 1. X is equal to what? Negative 1 over 4. Any question? Then you copy. Any question? A to the power negative 1 over 4 times A to the power 1 over 2 all over A to the power negative 1 over 2. Is that all? Then let me write it in the middle. A to the power negative 1 over 2. Are you all here? Write the question and put your pens down. Marcus, where is your friend? answer the mission. Saturday 9 o'clock. Not yet. Then you come and write it here in the next hall. Some will be here. Those who come early will occupy here. Those who come late. Another e to the power 1 over 2. All over a power negative 1 over 2. This is even too cheap for you. So who can tell us, how do we simplify the numerator? The pages are what? They say, what do you do to the powers? You add. So you're going to get a to the power negative 1 over 4 plus 1 over 2. All over a to the power negative 1 over 2. Can you add this to that? Let's use LCM. What is our LCM? 4. 4 divided by 4. 1. 1 times negative 1, negative 1. 4 divided by 2, 2. 2 times 1, 2. Negative 1 plus 2, 1 over 1, 4. So, our numerator becomes a. Is it positive or negative? Positive. It becomes a to the power 1 over 4. Are you watching? You have simplified the numerator. Indices at the top. All over, we have not done anything to the down. Negative 1 over 2. So we have applied law 1 to the top. Now we have this over this. Who can tell us? Law 2. When it's a fraction, what do you do to the indices? You subtract which one from which one? The down power from where? The top power. So you are going to get a to the power 1 over 4 minus. Is that not it? And there is a minus already. Can you all see? Minus 1 over what? 2. It is the same thing as a to the power 1 over 4 plus. Can you all see? Plus what? 1 over 2. So let's simplify the indices. What is the LCM? 4. I'm doing this so that everybody can understand how we simplify the power. Are you all here? So we have added this to that. So we are looking for the LCM, which is 4. 4 divided by 4 is 1 times 1, 1. 4 divided by 2. 2 times 1, 2. So we get what? 3 over what? 4. So that's the power we are going to get. So we are going to get a to the power what? A to the power 3 over 4. A to the power 3 over 60 raised to the power 1 over 3. 4 raised to the power 1 over 3. 1 over 8. There is no power there. Okay. Write a question quickly. And start thinking how we are going to work it. Write a question quickly and then start thinking how we are going to work it. Young one, are you following? 1 over 3 times 4 to the power 1 over 3 all over what? 8. All over 8. So the question is this: 16 to the power 1 over 3 by 4 1 over 3 all over 8. So, you go ahead. Are you all here? And apply that. So if this number was said that I can take the cube root of it and get a number, fine, I can do that. Likewise this one, you simplify them out first. That is one approach. Another approach is what we are doing. You can change each of them into what? Indices form. So change each of them into indices form. And when you are changing in such a way that you can have some common values running through them so that you can easily what? Simplify out. Are you all here? Yes. So 16. 16 is the same as what? This one is 4. So we leave this as also 4. When we finish, we can simplify. At the end of the day, we have to be able to have the same as what? 8. Can we simplify 8 to have base 4? No. But you can simplify these ones to have base 4. This is base 4. This is 16. So we can change this to have base 4. Fine. When you finish, and you now compare with this, you now have to rechange that and this to also have a common base. Is that not it? Yes. So what do we do? What do you want us to do? We change that to which? So 16 is the same as what? We should use 4. We should use 4. Okay. Somebody say we should use 4 first. So let's change this one to 4. To have the base 4. 4 to the power what? 4 to the power 2. Don't forget of this power. Are you watching? 16 is the same as 4 to the power 2. Is that not it? 4 to the power 1/3. Nice. We have done nothing to 4 to the power 1/3. Can you all see? Yes. We have done nothing to 8 yet. So let's go on. The third law of indices says what? When the powers are 2, what do? You multiply the power. So we get 4 to the power 2/3. Are you watching? Can you all see? The powers, multiply the powers. 2 times 1/3 is the same as what? 2/3. Times here. 4 to the power 1/3. 4/8. Are you watching? When the babies are equal, what do? You add the first law. So you have 4 to the power 2/3 plus 1/3 all/8. Are you watching? So I have 7 here is what? 3. Can you see? I have 7 here is 3. 3 divided by 3, 1. 1 times 2, 2. Plus 3 divided by 3, 1 times 1, 1. 2 plus 1, 3. Over what? 3. What do you get? 1. Are you watching? So our numerator is what? 4 to the power 1. If you want, you can put it there. Is that not what we had? We had 1. Because we have simplified our power and we had 1. Can you all see? So it's the same as what? 4. Can you all see? 4 to the power 1 is what? 4. all/8. We are doing indices. So don't cancel. Are you watching? Don't cancel. So let's go. 4 is the same as what? 2 to the power 2. all/8 is the same as what? 2 to the power 3. Are you watching? Yes. So, second law, when you are dividing and the bases are the same, what do you do to the powers? You subtract. So you have 2 to the power 2 minus what? 3. What you will still get the same answer, but don't cancel. What do we get? 2 to the power -1. 2 to the power -1 is the same as what? 1/2. I'll leave it here because we are doing indices. Are you here? Yes. So if in the exam it's objectives, you don't see 2 to the power -1 and you see 1/2, select it. Are you all here? So any number to the power negative 1, one of the properties, it says what? It's the same as 1 over what? That number. Can you see? So if you had cancelled here, you get 1 over. That's what we mean by that. So we are illustrating the property. So follow the rules. Times 2. What about 16? 1 minus n like this is equal to 4, 2, n. That's all. It's not a fraction. Like this, 4 to the power 2 n. Like this. They say you should do what? So for the part n. Write that quickly. Open the question. Your colleague is here to help us solve this question. So he's now the teacher. He's going to collect the mic and explain how to solve this question. Explain it. Okay. And to start this, you have to ask yourself this question. We have 64 to the power n multiplied by 2. And then
Are you watching?
all out of 16 to the power 1 minus n. So it's equals to 4 to the power 12. What do? We ask ourselves, what number do we raise to a certain number of powers? Then we'll get 2 as well, and this one too. What number are we going to take to raise to a power so that we'll also get that will also have the same base? So in view of that, when we take 2 to the power 6, we'll get 64. Then we say 2 straight forward to the power 6, and already the 64 is having n. Then we indicate the n as well. Then we multiply by 2. As 2 stands here is to the power invisible 1. So we write it. Then we divide it by 16. Okay. So now we have 16. The 16, we can have 2 to the power 4, giving us 16. So we have 2 to the power 4, that is our 16. And 16 itself was raised to the power 1 minus 1 minus n. So all is equals to 4 to the power 12. Right away, let's send the 4 into indices form. We can have it to be 2 to the power 2 as 4, representing 4, then all to the power 2n. So from here, we then come, dealing with the numerators, we have the bases to be the same. And if the bases are the same and they are multiplying, we add, okay, let's simplify this one first. So we have 2 power multiplying another power. We have 6n, 6 times n. Then we have 2 to the power 1. All out of, we simplify this one. So this one is better we put it in the bracket form so that everything will be affected. So we have 2, 4 to the times 1 give us 4 minus 4 times n will give us 4n. Is equals to, we have 2 power times power, 2 times 2n, giving us 4n. Good. So now, from here, we can have that, we can see that the numerator, we have the same bases, then and they are multiplying, we add the powers straight up. straight away. So we have write one of the base, then we add the powers. Dividing by a denominator, we have 2 power 4 minus 4n. All equals to 2 4.
Are you watching it? Watch and listen.
If indices, if we have a fraction and the bases are the same, we subtract the powers. So from there, we n plus 1 minus into bracket 4 minus 4n is equals to 2 the power 4n. So from here, we have a property that states that whenever the bases are the same, we equate the powers. Or even if better still, we can simplify the power here at the left hand side. Let's simplify it. We have 2 power n plus 1. A power 6n plus 1 minus, we remove the bracket. So minus times 4 minus 4 minus times minus 4n will give us plus 4n. All is equals to 2 to the power 4n. So from here, we simplify it again. We have 2 power 6. Okay, we group that term from here. We got 6 plus 6n plus 4n will give us 10n. Then we have 1 minus 4, we have minus 3 is equals to 2 4n to the power of 4n. Then from here, we can see that, we can see that the bases are the same. So if the bases are the same, we create the powers or the exponent. And then we have 10n minus 3 is equals to 4n. From here we do like this. 10 minus 4. 4 is positive here when we send it across. It's equals to 10n. Sorry. Minus 4n is equals to positive a. From here, ladies and gentlemen, we then do our operation. 10n minus 6n will give us 10n minus 4n will give us 6n is equals to 3. We divide both sides by the coefficient of n. This. And ladies and gentlemen, our n is equals to 1 out of 2. Is it correct?
Yeah.
How much for you?